Just a simple question for all of you. From the viewpoint of an average person, so to say, what would be the significance of your particular research from the viewpoint of this kind of average human being?
Who goes first?
I think you should go first.
Me?
Yeah, you have the
Okay.
easiest answer.
Yeah, it's pretty easy for me. I mean, if we think about the greenhouse gases, of course, it's related to climate change. All these measurements, they help us understanding the processes behind the ecosystem, greenhouse gas balances and so on. So it will help us to come up with better process models that can then be driven in the future climate scenarios, and then see how the ecosystem functioning will change in the future given the climate change and so on. But then on the other hand, there's also weather prediction models. They will also benefit from, especially from this, these studies related to low turbulent mixing during nighttime, because those are that kind of periods which are also really difficult for weather prediction models. They are not able to predict the air temperatures close to the ground in that kind of situations, just because turbulence is not kind of transporting the information close to the ground to higher levels in the atmosphere where the models are actually mostly working well. So I think those are just the two biggest things for normal people.
Yeah, so I don't think that the average person is very gonna get anything practical out of what I do. But there might be like some, like not specifically of what I do, like the epistemic risk thing. You might wanna, for instance, know what kind of rules of inference are valid for certain predicates like knowledge or justification, and that might be useful in some sense for some people. But then there are more applied epistemology that makes use of this kind of stuff. For instance, Miranda Fricker has recently argued about this kind of thing called epistemic injustice. So certain individuals can be epistemically wronged in that they are in such a social position that they are not able, either it's the case that they are not seriously recognized as epistemic agents, or they are in an improvised position where they cannot, for example, know that they are in a as good position as the others are with respect to someone, and this especially relates to minorities and so on, how they are treated in different things. So, like, in a roundabout way, these things tend to have some effects, but it's really hard to say, like, specifically of this kind of thing that I was talking today, which is like not the only kind of stuff that I do in epistemology, but like one part of it.
Okay, for my part, I would say if we go to the absolute practical, and I would say probably the most important application to the average person would be information retrieval. So let's say in the future, if you would, the more, let's say, computers understand about the structure of, let's say, websites or whether their documents or whatever, in the future you could instruct, let's say, find me an instruction manual. So based on the patterns that are typical to an instruction manual, that could then narrow down the search. And then an alternative, one could consider accessibility. So, I mean, for those who are visually impaired, you have a means of reading out the text in a document, but currently I think the ways of describing, let's say, automatically the content of images or diagrams and all other forms of like more complex multimodal forms of communication, that simply isn't there, and you need to do the groundwork before developing those kind of tools. So perhaps in that way.
at least the two that I could follow interesting talks. I'm assuming yours is also quite interesting. So with these when you measure, because you showed in the one of the first slides, you showed these weather balloons.
Yeah.
They I've always wondered, this is a very simple question, I've always wondered, like, can you just let them go everywhere? Or do you?
You need actually permissions to do that. So like I said, that's something that we did during a laboratory course, and it was always kind of it was the last thing that we did on that course, this sounding, and that was something that the meteorology students were always kind of waiting for, and they had heard from their other students that they will do this sounding and so on. So you need to inform people working at Helsinki-Vantaa airport and so on that we are planning to do soundings at these days from the Kumpula campus area. And then before you release the balloon, you have to call and ask that, can we do this now? Is there some plane flying just above the Kumpula campus during this time? And sometimes they have said that, okay, you have to wait for 15 minutes or so, but usually you can just release it there. But those are that kind of measurements that are all the time done for weather prediction models, because those give really important information for the models. I think there's at least 2 locations in Finland where those soundings are made all the time by FMI. I think it's like twice a day or something like that they are done. So that's kind of that's that kind of information that are then fed into the weather prediction models, and then the models will get more accurate weather predictions because they get this information about the temperature structure and also the humidity profile in the atmosphere. Yes.
About your work, so I was wondering, I understand well, of course, the weather predictions that you would look at the turbulences and so on, but then if you think about methane release or CO2, so wouldn't just simple measurement, be in a way be the thing to do if you would like to understand how much you have? I mean, why would you need the turbulence measurements? Maybe I misunderstood what you were telling. And then also I was thinking of the sort of horizontal movements. So of course, I mean, if you have a marshland, so it has edges, and I guess the methane is released also very much on horizontal way. So just to clarify what you meant in a way with this.
Yeah. So basically, you need to be far enough from the edges. So you need to be quite in the center of the wetland or peatland.
Think about it, that you just
so that you can kind of assume that there's horizontally not that much variability, so that you can assume that what comes out from the surface actually that is transported through the roof of the imaginary box. So, but then related to the turbulence, I mean, so maybe I wasn't really clear in the presentation, but the turbulence is the thing that is kind of transporting the methane through the roof of the imaginary box, and this is the kind of the only way how you can measure the whole ecosystem gas exchange. There are these kind of ways where you can go to the peatland or the ecosystem that you want to measure, and basically you put a box on top of the peatland, and then you measure the methane concentration inside the box, and then it's increasing because there's a methane release to the box. So we don't have any more imaginary box, but we have actually a real box on the peatland, and then you get the methane emission from this exact location. But the thing is that you have a lot of spatial variability on small scales, and if you want to have a representative estimate of the whole ecosystem emission, then you basically should measure the whole ecosystem at once. And this is the most convenient way to do those measurements continuously all the time. there is not this kind of other methods. These are kind of the only ones. One way also is you can have really tall towers. You need to have tall towers where you measure the concentration of the gas that you're interested. And from these tall towers, if you have a tower here and another here, and then you have a source in between, and wind is blowing in this direction, you will have a concentration difference between these towers. Because you have a source here, and then it's transporting, let's say, methane or CO2 to the other place. And from these concentration differences, you can actually backwards calculate the emissions. So this is another way to estimate the large-scale emissions of different gases. But that usually mixes up the sources from different locations more. So then you cannot say that these emissions came from this exact peatland, or so it's a different scale. We were kind of having these different methods in different scales, and this one that I was talking about is the kind of the ecosystem scale on order of hectares.
But anyway, I guess it is that because of the turbulences and because of the turbulences, you anyway rather quickly get the sort of the concentrations will be evened, or will be sort of
above the peatland you mean?
I mean that when it's a CO2 release somewhere or methane, so they will be then affecting rather. I mean, they will rather quickly go to 100 kilometers away. I mean, so this is the fact in any case, wherever they come from.
So with these tall towers, if you want to see the emissions on the ground, you need to measure the concentrations really precisely, so that you can see, like you mentioned, to see the concentration difference at these two different locations, which is related to the source at the surface. So then you need to do really precise measurements of the concentrations. And still, it's quite difficult, but this is the way how it's often done.
Yeah, I was wondering in what kind of terms have linguists and other people who study multimodality aimed at defining modes of communication? Like, what kind of factors do you use in your definitions?
Okay, one quite common definition builds first of all on the idea that one needs to have some kind of materiality in order for something to exist, whether it's sound waves or some physical substrate carrying, let's say, that small booklet over there. So one would need to have some kind of materiality capable of carrying some material traces which have a syntagmatic and paradigmatic organization, so which enable you to combine things and make choices. So language is one of those whose organization has been described to, I wouldn't say precisely, but quite extensively for many natural languages. And then the final component would be what is typically called discourse semantics, which simply means the kind of mechanisms that support the process of interpreting some mode of expression in a given context. So in language, for example, we know a lot about these mechanisms that help us to make sense of language as it unfolds, let's say in some written text and so on. So those three criteria, so materiality and then some kind of syntagmatic, paradigmatic organization, I would say just some kind of internal organization, and then support mechanisms for making sense of that material in context. Those would be the kind of defining qualities.
Yeah, thanks.
Yeah.
So how about the choice thing though? So does that mean like you can represent different kind of things with or communicate different kind of things with that material basis, or like?
Yes, but I would say that for some cases, I mean, the materiality pretty much restricts your choices. So I would say that unless you have something, let's say, a digital screen that enables this kind of like dynamic re-rendering of the content at all times. Well, you cannot realize a film on a sheet of paper, really. You need something else, and then let's say some other properties that are relevant might be, let's say this kind of face-to-face conversation unfolds in time, whereas let's say something else like that operating system on the screen unfolds in space, but then something else like film might unfold temporally and spatially and so on. So it really depends. And I mean, for language, I mean, that kind of choice thing, just to give an example from language, would be the kind of choices that we can make. We can express the same thing in different ways by using different kinds of linguistic structures. So that would be the kind of choice that you have there.
Good, thanks.
I was, because first I was thinking, listening to your modality talk that this would be difficult. This is, I mean, would just want to get out of it. But then when you refer to the application in artificial intelligence, so then I thought, oh, wow, this is pretty neat, because of course, I mean, as an example, if you just look at a picture, but then if you look at arrows, if you look at how the sort of signs are there, what other elements you bring in, so then it makes already sort of, how to say, it makes links between the different things which you see there. And then I was also thinking that, okay, is this then by necessity relying or benefiting a lot from the point that at least we scientists, we put up things in PowerPoint. We can of course add a video there, we can add a picture, but still we are very much using the markings or the I don't know what's the correct term. We have an arrow going one way, we have an arrow going two ways, and this has quite a lot of significance. I mean, for a scientist, if you put it one way or two ways. And this is of course something which artificial intelligence can read. And so how much actually are we relying then on these kind of pictorial elements which we are using, and of course we can use them wrongly also, but that it is standard, and now we are starting to have standard pictures for whether it means energy, whether this means renewable materials, so we have standard pictures like this. So yeah, so is that of great help that we have PowerPoint?
It's. I would say that. I mean, if we look at it from the let's say perspective like modern AI, you can train a neural net to regress values from, let's say, a bar chart. That's doable, and has been done recently, but only if you have similar data in the training data. So the problem is for AI and for, well, generally like, let's say, describing the meaning of arrows, let's say in scientific publications or presentations in a conference or in a completely different context, is that especially the word context. So what does that arrow mean in context? And that's the difficult part for AI. So, and generally it's a problem for us as well. So to what extent, let's say, the making sense of diagrammatic elements in diagrams depends on the context, and how much does it depend on domain knowledge, like let's say chemistry or atmospheric sciences, or actually you had a diagram as well, so it's not that remote from philosophy either.
We have diagrams all
exactly. So I would say it's, yeah, exactly. So the question is like how much of that domain knowledge you need, and can you model all that domain knowledge? Probably not, but you can maybe make some inferences in context. So what do they mean and so on. But the problem is that obviously the most of the advances in recent years have focused on photographic images, and those don't really benefit this kind of like complex combinations of natural language and all sorts of graphical elements. And I think it's quite interesting, and to take something like very time-tested like graph theory and graphs and use them to bring those different components together and then see whether you can actually benefit from that kind of approach. And of course, I think it's just nice, opens up a lot of possibilities for collaboration as well. So I'm going, for example, to the States next week to talk with some computer scientists who have been working on the same data set, using it to train these kind of visual question answering algorithms. So basically, using the data set that I showed, you can do, the data set comes with a question answer set. So you have things like, questions like, what does the fox eat? And then you train the model, and the algorithm automatically decomposes the diagram and looks for an answer. And they were quite excited because the crowdsourced descriptions are a bit, how would I say, of low quality every now and then. So they were very interested in having this kind of like very detailed description and seeing whether that actually improves the performance of computational models for diagram understanding. So there are a lot of like these kind of interconnections.
Quite interesting. I hope we are not going wrong in these predictions.
I have maybe also about the multimodality. So if I understood correctly, you have these diagrams and charts and so on, and then you're kind of deducing some kind of important information from those, and then trying to find general patterns, right?
Yes.
So can you, based on these general patterns, can you somehow group the different kind of diagrams in similar kind of groups? And
Yes.
And do you find many groups, or do you find, let's say, surprising groups or connections between the different kind of
We haven't done any clustering yet, so we're doing some experiments with the graph neural networks at the moment. But the thing is, already like, let's say, qualitative approach, looking at the data, it's interesting in the sense because you have these kind of prototypical patterns like for all sorts of basic things like networks and cycles, but then you see combinations of these prototypical patterns, like let's say you might have a food web, and then for some reason one node in the food web has been described using a call out, so you have this kind of like zoom in structure, and then you have the same structure there, which would be typically encountered in a situation where you describe some object and its properties. And I think these should be learnable by a model, and thus I also assume that these should be fall like somewhere in between if one would run some kind of clustering algorithm on the data. But the problem is, like I said, to find these kind of meaningful patterns, it's difficult to query these kind of graphs because most of the methods that we have from linguistics are designed for linear data. So whether it's spoken language or written language, just lines and lines of text. And those are not really usable for this kind of like spatially organized things like diagrams. So we need to come up with new methods for that as well. But I would say yes. And like I had the reference in the last slide, it's for me, I think it's quite remarkable that the state of the art actually in diagram understanding, it's pretty much hand engineered features still, so they cannot be learned directly. But you take important information like location in the diagram, the type of the element, and then its connections to other elements, and that actually gets you to the state of the art in diagram understanding. No visual information whatsoever.
Right.
And if you try to do that with photographic images, it doesn't work at all.
I wanted to say to Jaakko, so I think that for the question of abnormal people or laymen, sort of what could be the message, I think that provided that you could maybe explain it a little bit in more simple terms, but the lottery case I think was very illustrative in a way of how one is thinking, and because also the probability, I mean, it gives you, I mean, what is science also, in a way that we are playing with probabilities, and then there is also truth and so on. So I think it opens up very nicely also for the layman, the sort of scientific questioning from your point of view, even though you say that philosophy is not science, but still it's sort of the pondering. I mean, how do we grasp, how do we understand the world, and how do we make also the assumptions what is true and not true. And I think it's important that we all scientists from different angles now also try to explain, I mean, how do we come to scientific conclusions, and that it's not, nothing is, or very few things are actually completely solid in that sense, but still we can, as you said, we can deduce and we can go forward.
Yeah, so I think like for laymen there's probably not much of practical interest in philosophy, but of course philosophy in itself is hugely interesting. Like, I think it's one of the most interesting stuff in the world. And you know, many philosophical questions are really interesting. Like, questions about what's the purpose of life is very boring, but there are like genuinely interesting questions that have like good answers. And it's not like that they are unanswerable in any sense. These questions that I was like pitching today, they have correct answers. Probably both of the views that I was pitching were false, but that doesn't mean that there wouldn't be a definite answer that couldn't be found out in a rigorous way. Like, philosophy is not science in the strict sense that we don't really have like that much empirical stuff going on and so on. But it's kind of like, yeah, I think I'm happy not to say that philosophy is not the proper science, and it's better that way. Yeah. Because then people start to get all kinds of impressions that philosophers are telling them something about how the world works and so on.
Still maybe a final question, because before you were saying that you like this deduction in a way that you go forward through deducing from the previous knowledge. I had actually, prior you said that, I was thinking, should we actually try to dig out what are the non-probable things? And would that be a way for getting to something radical? And this probably is a difficult question for you, but I was thinking whether you have sort of analyzed, or somebody has analyzed, that actually how much, I mean, let's say scientific discoveries or something are really on that that people, let's say, beforehand would have gone for the non-probable, or later on found out that this was really improbable, but now it's true. And of course there are examples, but it's tricky.
Yeah, good. So think, for example, about physical laws, and there are some like constants in the universe. If these constants were even slightly different, then nothing would be as we think it is. Everything would be radically different. Now the question is whether those constants can change. Some people think that they can. They could be different. Yeah. And then life as we know it is hugely improbable in every sense. And there are other ways as well in which like improbable events happen all the time, but like, for example, there's like at my home now, there's this much ice, like this much out from the roof. It's hanging in the air like this. I'm thinking that it's gonna fall. I'm not gonna walk underneath it because I'm at risk of dying. But the probability of dying in that is extremely low, but I'm still not willing to take the risk. But it's very, very low, because at any given moment when it's actually gonna fall, it was hugely improbable that it fell that moment.
Yeah, but I think we may, or I would like to end here in a way on that, or based on that your statements which you made and what you opened to us. So that opened up sort of a thinking really in a way that what could science be and what could our understanding be, and this is very important. Because very much of what is done is based on deduced thinking, which is very good, of course, because then we can have a solid thing and solid stuff around us, and it's useful. But it's something the human mind enjoys, of thinking what could be the improbable truth. Okay, thank you. Are we happy for this evening?